In this video, we'll be introducing STAR and providing a brief tutorial on the basics of using STAR. STAR stands for Splice Transcripts Alignment to Reference and is one of the most commonly used RNA-Seq read alignment tools currently available. The software was developed at Cold Spring Harbor Laboratory. RNA-Seq datasets typically consist of tens to hundreds of millions of short RNA sequence fragments. Most RNA-Seq read alignment software attempts to map these short reads to a reference genome. Large genome sizes, as well as the high quantity of reads in the RNA-Seq datasets, often cause the read alignment task to be both computationally intensive and consequently very time-consuming. STAR addresses both of these issues. STAR works by first generating genome index files from raw sequence data from a chosen reference genome. These indexes are automatically annotated and saved to disk, so they only need to be created once for each reference genome. What's unique about these indexes is that they are built on suffix arrays, which are speed-efficient data structures for searching the maximum mappable length of a read during the read mapping procedure. It is these suffix arrays that enable read mapping with STAR to be notably faster than other comparable read mapping tools. Some indexes of reference genomes are available online for download in the link provided, but it is generally recommended that users generate their own genome indexes with up-to-date assemblies and annotations. The files that comprise the set of reference genome index files include information on binary genome sequences, suffix arrays, chromosome names and lengths, splice junction coordinates, and transcripts and genes. Most of these files use internal STAR format and are not intended to be directly handled by the user. Once these reference files are created or obtained, we can begin the read mapping process. Here we present an example of a read mapping job with the basic options. We must first install or load the necessary software for using STAR. For users of the Odyssey computing cluster at Harvard, please refer to the link provided in the video to identify the most up-to-date modules and dependencies for STAR. After you have done this, we can go ahead and begin to put together the command used to perform the read alignment. There are a few basic inputs that are required for running the STAR read aligner. The first is genome dir, which we use to specify the path to the directory containing reference genome index files. We also have the run threads end parameter that enables us to specify the number of threads to be used for mapping. Note that the number of threads that is used for this parameter must be within bounds of the number of available cores on the server node. Lastly, the read files in parameter is used for us to specify the path of the files containing the sequences to be mapped. STAR supports both FASTA and FASTQ files, so either of these formats are compatible for this read mapping procedure in STAR. Here's an example of what the command should look like with simply the set of basic options. As you can see, the command begins with STAR, and we see our genome dir, run threads n, and read files in options, alongside the inputs that we seek to use. We also have an out file name prefix option that will simply provide a prefix to the set of files outputted from this job to facilitate the organization of the outputted data later on. In this example, we made sure that our output files contain the prefix STAR single. It's important to note that in this particular example, we perform single n read mapping, so only one FASTQ file is inputted as a parameter under the read files in option. In this second example, we perform paired n read mapping with paired n reads from two separate FASTQ files, so we provide two files as input after the read files in option. All other components of the command remain the same. We run this command, and after the read mapping procedure is completed, we expect to have generated three output files: a log.out file, a log.progress.out file, and a log.final.out file. The log.out file provides a ton of in-depth information about how the job was run and is mainly used to help with troubleshooting and debugging. You can see a portion of this file here, and we see that a lot of this information isn't directly useful for performing downstream analyses. The log.progress.out file gives us information on the progress of the job, including stats on the number of processed reads and the percentage mapped. Finally, the log.final.out file provides us with the summary mapping statistics, and it's here that we can find a lot of useful information about the performance of our read mapping procedure. We can find data on the number of uniquely mapped reads, the percentage of uniquely mapped reads, the average mapped length, the number of splices, as well as statistics on multi-mapping reads, unmapped reads, and chimeric reads if applicable. So this covers the basics of read alignment using STAR. For more information about STAR, including information on advanced features and troubleshooting, the best place to look would be the official documentation for the software. We included the link here in this video if this is what you're seeking. A link to the GitHub repo for STAR is also included and contains the most up-to-date information about installation, documentation, and actual source code. Thanks for listening, and I hope this video was of help to you.